Okay, let's go over this problem here quick, see how you're doing or how you did on it. So as we look at this, you recall from last week, one of the formulas we had that dealt with solutions and mixtures like this was that the amount of that active ingredient, we're going to refer to it as, it's kind of showed up wrong, serum, is equal to the concentration. Remember that concentration is the percent as a decimal times the total amount of solution. And that total amount of solution can either be a volume or a mass. So let's take a look at what we have in this problem. We have our total amount of serum that we're looking for, or not that we're looking for, that we're given here is 210 milligrams. So 210 goes in for the amount of serum. Our concentration is that 30%. Now remember, the concentration is a percent as a decimal. So I put that in as 0.3. And then times the total amount of solution is what we are looking for. How much total solution? So that's going to be our x. To solve this, we simply divide by the 0.3. You get 700 equals x. Now that 210 was in milligrams, so our 700 is in milligrams. So 700 milligrams of total solution can be created. Now, this is a very important formula for us because one of the things that we look at quite often in medical medicine mixing and stuff like that is combining solutions. And when we are combining solutions, we have to worry about that concentration. We're going to start out from a very simplistic point of view and then get into a more practical point of view as we go. But let's start out with a situation where we are going to mix two solutions. Let's say we are going to mix 200 milliliters of 18% solution with 600 milliliters of 26% solution. And we want to know what is the final concentration. Now, we're not, again, like I said, it's not a terribly useful problem because we're not going to stand there and randomly mix solutions together and see what we get. Most of the time, we're going to have a target we're shooting for. But we're going to use this to build up to that more complex calculation. So as we look at this here, there's a couple of things that have to be constant. I'm going to call this part up here the 18% solution A and the 26% solution B. And what we know is the amount of serum in solution A plus the amount of serum in solution B has to equal the total amount of serum because we're combining the two solutions. But the other thing we know, now we're going to make a slight assumption here, and that assumption is that we're using the same solute, that both of them are dissolved in water. We also know that the total volume of A plus the total volume of B has to add up to the total volume of the total mixture. So how do we use this to our knowledge? Well, let's map out what we have here. We have the 18%. That's solution A. We are mixing it with 26%. That's our solution B. And we're going to get some unknown percent. That's what we're trying to find, is what is that final concentration or final percent. So we're going to get X, some unknown percent. The amount that we have of each? Well, we know we have 200 milliliters of the 18%. We know we have 600 milliliters of the 26%. Now, because of this second formula, volume plus volume has to equal total volume, we know that the final amount that we're going to have is going to be 200 plus 600, or 800 milliliters. So now from that, we're going to create an equation. The amount of serum, the medication in solution A, is going to be its concentration. 18% will be 0.18 times its volume of 200 milliliters plus the amount of serum in solution B is going to be its concentration, 0.26 for the 26%, times its volume of 600 milliliters. And that has to add up to, has to equal the amount of serum in our final solution, which has a concentration of X. So that's X times its volume will be 800 milliliters. And now we can use this equation to solve. Now remember, there are certain steps we go through to solve. Step one is to see if we can combine or simplify on one side of the equation. And we can. On the left side over here, we can do 0.18 times 200, which is 36. We can also do 0.26 times 600. So let me get this out of the way. 0.26 times 600 is 156. Equals X times 800. We're just going to make that 800X. Now there is still something we can combine on the left side. 36 and 156 will combine to give us 192. So we get to the equation 192 equals 800X. Now we've simplified everything we can on both sides. The next step would be to make sure to see if the variable appears on both sides or on just one side. And the variable does appear on just one side here, so we can solve. We'll divide by the 800. So now we divide. 192 divided by 800 is 0.24 equals X. So 0.24 is the concentration of the final solution. That is a 24% solution. Now, as always, we should make sure we go back and have answered the question. So we go back up here. What is the final concentration? And yes, that is the 24%. Well, like I said, it's not very practical to do this type of calculation. It's not very often that we're just going to randomly mix two solutions together to create some random solution and figure out what that turns out to be. Most of the time, we have some target that we're looking for. For example, let's say we're going to ask how much 36% solution should be mixed with 240 milliliters of, what do I want to put in here? Let's do 18% solution to create 30% solution. So here we have all the percents, all the concentrations. We know that we are using 36 and 18% solutions in an effort to create a 30% solution. And we know the volume that we have of the 18%. So let's take a look at this. We have 36%. We're combining with 18%, trying to create 30% solution. Now we are asked how much of the 36% solution. So the amount of the 36% is what we're looking for. So I'm going to make that X. We know that we have 240 milliliters of the 18%. So the amount of the 18% is 240 milliliters. What that means for us is the amount of 30% going to be found by adding those two amounts together. That'll be X plus 240 milliliters, or X plus 240. So I'll pause there for a second. Does anybody have any questions as to where I got this information out of the problem? Okay. So now the next step then is to set this up. We have the two ingredients. These are the two ingredients, and this is our final result. So we look at the amount of that serum, that medication, that is in each of the ingredient solutions. So for the first one here, we have concentration of 36%, so 0.36, times X. We don't know the amount. For the second one, we have a concentration of 18%, so 0.18, times, that amount is 240, equals, for our final solution, we have a concentration of 30%, so that's 0.3, times an amount of X plus 240. So here's my next pause. Any questions as to where this equation comes from? Okay. So now our next step, as always, to simplify whatever we can on each side of the equation. So on the left side over here, 0.36 times X is just 0.36X. 0.18 times 240 is 43.2. Equals, on the other side, 0.3 times X is 0.3X. 0.3 times 240 is 72. Now we've simplified everything we can on each side. Our next question is, does the variable appear on one side or both? And in this case, it appears on both sides. So we have to get rid of one of them. The smaller is the 0.3, so that's the one we're going to get rid of. It's positive, so we get rid of it by subtracting 0.3x. That's gone, leaves us with 72 on the right side. We have to subtract it on the left side as well. We can only subtract it from the 0.36x. So 0.36 minus 0.3 is 0.06x. Plus, we still have that 43.2. So now there's nothing left to combine. We have the variable down, so it's only appearing on one side. We can start to solve. We'll subtract the 43.2. It's gone on this side, leaving us with 0.06x. On the right side, 72 minus 43.2 is 28.8. Final step then is to divide by the 0.06. X equals 28.8 divided by 0.06 is 480, I believe. Yep, 480. So again, we need to make sure we go back and answer our question. X is 480. That is the amount. That would be in milliliters because this was all in milliliters. That's the amount of the 36% solution. Now let's make sure that was what we were asked for. We were asked how much 36% solution. So we have answered our question, 480 milliliters. Now, That type of a problem occurs in a lot of different forms. One might look like this. Let's say you have 120 milliliters of 42% solution that needs to be diluted to, let's go 14%. How much? Now I'm going to put in a term here that we'll talk about in just a second. NS should be added. So I threw in a term here, NS. NS is a generic term that we use in a lot of the medical fields, and it has a couple of different possible meanings. NS can stand for normal saline. Normal saline just basically means sterile water. It is a sterilized water that's been pH balanced to match the pH of the body. So it might have a slight, very slight amount of minerals added to it to match the body's pH. The other interpretation of NS is neutral solution. In either case, NS has 0 active ingredient. In other words, no medicinal value. In the medical field, it's what we refer to as a vehicle. It has no medicinal value whatsoever. It does not affect the medications at all. It's what we use to carry it into a patient. So NS is 0 active ingredient, means 0% concentration. So what we're looking at in this situation is we have 42% solution. We are looking at combining that with a 0% solution, that's the NS, to create a desired solution of 14%. We look at the amounts we have, 120 milliliters of 42%. What we're going to be adding to that is the 0% or the NS. We're asked how much of that's going to be added. I'm going to let that amount be my X, my unknown value. So then the amount of 14% that we're going to have is going to be 120 plus X. So now we need to write this equation. Well, 42% is 0.42 concentration times 120 milliliters plus, for the saline, it's the amount of serum in there. Well, it's 0% concentration. So that's 0.00 times X equals, on the other side, our final result, we want 14%. So that'd be 0.14 concentration times the amount will be 120 plus X. Now you might be looking at that thinking we didn't need this part. 0 times X is just 0. And that's true, but putting it in there does keep that relationship of the two ingredients, the two amounts of the ingredients have to equal the total amount. But yes, that's going to multiply to make 0, so that's going to disappear. So we have 0.42 times 120. Which is going to give us 50.4. On the right side, we've got 0.14 times 120, which is going to be 16.8. 0.14 times X is a 0.14X. From here, then we need to go ahead and solve. There's nothing more to combine on each side. The variable is only on one side, so we can go ahead and solve it. We're going to subtract the 16.8. So 50.4 minus 16.8 is 33.6. Equals 0.14x. And finally, we divide by the 0.14. So 33.6 divided by 0.14. We get 240. So x equals 240. So again, we're going to look back at the problem, make sure we identify what x really stands for, and then make sure that answers our question. So x is the amount of the 0% solution, or the normal saline here. So there were 240 milliliters of that. And we look up, and yes, we have been asked how much NS we needed to add. It says 240 milliliters of that normal saline. Any questions there? Okay. Well, the opposite side of that might look like this. We might have how much pure alcohol. Alcohol, of course, I'm talking about rubbing alcohol. How much pure alcohol should be added to 180 milliliters of 36% solution to create let's see here, a 52% solution of alcohol and water. And again, we're going to say alcohol in NS. So what we have here, we have a 36% solution. What we're going to add to that, how much pure alcohol? Pure alcohol, we're assuming is 100%. Hence the word pure. And we're going to try to create a 52% solution. So now we look at amounts. The only amount I'm given here is 180 milliliters of that 36%. We want to know how much pure alcohol should there be. So we're going to let the amount of the pure alcohol be X. So then the amount of the final solution will be 180 plus X. Now this might look very similar to the last problem we did, and it is similar with one very important difference. So as we set up our equation, the original solution we have is 36%, so 0.36 times its amount of 180 milliliters. We're adding to that. Now this time instead of 0%, we have 100%. So instead of being 0, 100% is actually a concentration of 1 times the amount of X. And that's going to equal our final solution, our desired solution. 52% is a concentration of 0.52 times its amount of 180 plus X. So now we're going to go ahead and, as always, try to combine whatever we can on each side. On the left side here, we have 0.36 times 180, which I believe comes out to be 64.8. Let me double check that. And yes, it does. Plus 1 times X is just X. That's all we can combine on the left side, so we're going to go to the right side. 0.52 times 180. I believe that is 93.6. Double check that. 92.6 works. 0.52 times x is plus 0.52x. Now there's nothing more I can combine on the right side. So the second thing we have to look for is the variable on just one side. And in this case, it is not. There's a variable on each side. So we have to get rid of one of them. The smaller one is the 0.52. So it's positive. We're going to subtract the 0.52x. That leaves us with just the 93.6 on the right side. We have to subtract 0.52x from the left side. We're going to subtract that from the x. Remember, we'll think of that as just a 1x. So our 64.8 is unchanged. 1 minus 0.52 is 0.48x. Now we've combined, we have the variable on one side. Now we can proceed to solve. So we will subtract 64.8 from both sides. So we have 0.48x equals 93.6 minus 64.8 is 28.8. And we will divide 5.48. So x equals, I believe that comes out to be 60, but let's double check it. 28.8 divided by 0.48 is 60. Very good. So x is 60. So again, we have to go double check to see what x is and make sure that answers our question. X is 60. That's milliliters because we're talking about that's the amount that's been used here. That represents the amount of pure alcohol. As we look back to the problem, yes, we are asked how much pure alcohol should be added. Any questions so far? Okay. Let's look at this one. Let's say we have (7% and 10% solution. How much of each should be used to create 240 milliliters of 9% solution? Now, before I even start this problem, we can see it's slightly different, but I do want to look at just breaking down by the percents. Our ingredients here, what we're putting in. So as we're saying, this problem here, we are mixing two ingredients, the 7% and the 10%. And we're trying to get a final result of 9%. So that's where we're going to start out here. Now we'll notice that our result, the 9%, is closer to the 10% than it is to the 7. So what that's telling us is we're probably going to use more of the 10% than we are of the 7%, because the final result is going to be closer to that ingredient. So now let's look at how we're going to label our amounts here. The only amount we are given is the 240 milliliters, and that is of the 9%. So we are going to end up with 240 milliliters of our total solution. So the amounts of the 7 and the 10% are both going to be less than that amount. So we need to pick one of them to be our variable. I'm going to pick the amount of the 10% solution to be X. Now, the reasoning behind that, when I have a problem like this where I don't know either of the ingredients, I always let my unknown volume be the higher concentration. 10% is a higher concentration than 7%. The only reason I do that, it would work out either way. The only reason I do that is because it avoids working with negatives. So now then, my 7% solution, the amount there, if I have a total of 240, the amount of 7% is found by taking that total of 240 and subtracting the amount of 10%. So that's going to be 240 minus X. So now we can create our equation. So the first ingredient, the 7%, is going to have a concentration of 0.07 times an amount of 240 minus X. The second ingredient, the 10%, has a concentration of 0.1 or 0.10. If we were in a chemistry class and working with significant digits, we would want to keep the 0.10. And here it's not such a big deal whether we do or not. So 0.10 times X equals our final amount, the concentration of 9%, becomes 0.09 times that volume of 240. So now again, we need to simplify or combine anything we can on each side. On the left side, we have 0.07 times 24, which I believe is 18.8. 0.07 times 240, I should say, which is actually 16.8. Good thing I double checked. So we get 16.8 from 0.07 times 240. 0.07 times negative X is a negative 0.07X. We also have the 0.01 times X, which is just a positive, or sorry, 0.1 times X, which is just a positive 0.1X. On the left side, we can still combine negative 0.07X and positive 0.1X. So we've got the 16.8. Negative 0.07 and positive 0.1 is a positive 0.03X. Equals, on the right side there, 0.09 times 240, I believe is 21.6. We're going to double check that. And it is 21.6. Now, the variable only appears on one side of the equation, so we can go ahead and solve this. So we are going to subtract 16.8 from both sides. So I have 0.03x equals, over here, 21.6 minus 16.8 is 4.8. And finally, we'll divide by 0.03. So that's gone. X equals, oh, what does that come out to be? 160, I believe, milliliters. So X is 160. Now we have to double check to make sure I know what X represents. I go up to my original problem. X represents the amount of the 10% solution. And it is milliliters because my other units were in milliliters. But I have to check to see what the question's asking. It wants to know how much of each ingredient. So the 160 represents the 10%. For the 7%, it's 240 minus X, or 240 minus 160, be 80 milliliters of the 7%. So now a little flashback. Remember at the beginning we said, because the result, 9%, is closer to the 10%, it'll take more of the 10% and less of the 7%. And that rings true here. We have 160 milliliters of 10% and only 80 milliliters of the 7. There are a lot of applications for this type of formula. You know, this application here of solution mixtures or combining mixtures in the medical fields is just one of them. Another application we have is in investments. So let's say that Pete has, let's say, has $10,000 to invest. In a combination of, let's do 4% and 9% investment. Now you might ask, why would Pete not just put it all in the 9%? Well, there's probably risk factors, a chance of loss or whatever that goes along with each of them. If Pete wants to average 7% gain, how much is invested in each? This is the exact same type of problem. Only now we're not mixing solution concentrations, we're mixing investment yields. We have 4% and 9% that we are mixing, trying to create a 7% overall mixture. We're going to have a total of $10,000 in that 7% overall. That's their total investment. We now need to split that up into what amount goes into each of the others. Now, once again, I'm going to let X be the amount of the higher percent, the 9%. So the 4% will be 10,000 minus X. Now, we may run out of time before we finish this one, but that's okay. We'll go ahead and get it set up here. So now we got the concentration, or in this case, the percent, the rate of 4%, 0.04, times the amount of 10,000 minus X. Plus the 9% will be 0.09 times the amount of X is going to equal the 7%, or 0.07, times that amount of $10,000 total. So here we go ahead and combine on the left side. 0.04 times $10,000 is $400. 0.04 times negative X is a negative 0.04X. We have the 0.09 times X is 0.09X. So now on that left side, we can still combine the X's. That'll give us 400 plus 0.05X. On the right side, we're just going to combine the 0.07 times the 10,000 is $700. Solving for X, subtract the 400. 0.05X equals $300. And we divide by 0.05. X equals $6,000. So again, let's look to see what X is. X was the amount of 9%, so $6,000 there. 10,000 minus X would be 4,000 and the 4%. Okay, we are out of time for the day. We've got about 40 seconds here before we lose the network. So the mixture problems, these are ones to pardon me? So on page 53 through 54 is 1 through 15. These are the problems that students will struggle with the most on this next test, on the Unit 2 test. So make sure you've done a few of these. On Wednesday, I have no problem taking time to go over some of these if you have questions. So make sure you've given a good share of those a shot. Anybody have any questions before we lose our connection? Okay, we'll see you on Wednesday. Remember, there won't be any class this Friday. I think some of you are actually going on Monday as well, but we are going to go ahead with class next Monday. So we'll see you on Wednesday. We'll go over some of these mixture problems if there's questions, and then we'll move on into more of the measurement. You guys have a great day.